As we've previously discussed, the domain name system, or DNS, is commonly manipulated, and as such, it's important to gain a better understanding of the nature of that manipulation, where and how often it tends to be occurring, and what types of domains may be manipulated by certain ISPs, countries, or both. Detecting DNS manipulation is actually a lot more challenging than it sounds. A strawman approach to this problem might be to look up a domain name from a number of locations or a number of different ISP resolvers and find instances where the IP address that's returned doesn't agree with the quote-unquote right answer. Now, the problem with this particular strawman approach is that there's typically not a single right answer or a single IP address that maps to a domain name, particularly if the domain name is for a popular web service. Here's a picture, for example, of the IP addresses that are returned when one tries to look up google.com. And this study was done almost 10 years ago, and so you can imagine that the geo-replication that now exists is far more extensive than even this picture depicts. In lieu of measuring a response against a single right answer or ground truth, one can look for so-called consistency metrics. When performing a lookup, one can try to characterize not only whether the name returns the same IP address, but also if the IP address returned corresponds to the same autonomous system or internet service provider. One can also look to see whether the web content that's returned from a particular GET request is consistent or the same across regions, keeping in mind, of course, that regionalization effects may also come into play here. One might expect, if we're talking about the Secure Web Protocol, or HTTPS, that the web request would return a common certificate from all of the different vantage points, as there's no good reason for a secure web certificate to vary across vantage points. One could also try doing what's called a reverse DNS lookup, or looking up the IP address and seeing what domain name the IP address corresponds to. Doing so typically won't yield the original domain name, like facebook.com or nytimes.com. Instead, you might get some kind of inscrutable domain name that refers to a content delivery network on which the domain name's content is hosted. But if we can expect that a particular website's content is hosted on a common content delivery network, even if it's geographically distributed, then we might expect to see some consistency in that reverse DNS lookup. Because there are good reasons for all of these metrics to exhibit some kind of inconsistency, when we looked for DNS manipulation, we only flagged the potential for manipulation if all 5 of these consistency metrics failed, if the metrics were inconsistent for all 5 of these metrics at once. Another way one can search or try to characterize DNS manipulation is through so-called independently verifiable metrics. One can look at, for example, the content of the HTTPS certificate, noting whether the IP address presents. We can see, for example, whether the IP address corresponding to the domain name lookup presents a correct domain in a valid browser-trusted certificate. And we can also perform the same test, but fetching the certificate with the so-called service name indicator, or SNI, and then check whether the domain name that's returned in the certificate corresponds to the domain name that was looked up. In a previous module, we looked at the prevalence of DNS manipulation by country, and one can see here that if we use these consistency metrics as a baseline for trying to understand whether manipulation exists, we can see that manipulated responses do appear to occur in some of the countries where we might expect those responses to be. We can also see in the data here some interesting aspects. In particular, we can see certain websites in various categories such as gambling, pornography, and peer-to-peer file sharing as being censored in many different countries and many different resolvers across those countries. And further down the list, we can see certain specific sites, social media sites, video sharing sites like YouTube, Google, and so forth, being censored or manipulated in a smaller number of countries. In the left side of the slide, we can see how DNS manipulation varies across resolvers for different domain names within the same country. And what's curious about these particular results is that we can see that DNS manipulation is not consistent across all of the ISP resolvers that we tested in any given country. Some DNS resolvers appear to manipulate almost none of the domain names that we tested, whereas other resolvers in certain countries can manipulate upwards of 80% of the domain names. It's unclear from this preliminary study why we're seeing these inconsistencies, And digging into this deeper and understanding the true nature of these inconsistencies would be an excellent avenue for future work. This could either be some artifact of the way the measurements were conducted, or it might actually be a manifestation of what we've talked about as so-called porous censorship. In summary, inconsistent DNS responses do occur regularly, but attributing causality, for example, to overt manipulation, can still be very challenging because DNS inherently gives inconsistent responses due to localization, and these responses may differ over time by ISP within a particular country, by region within a country, and so forth. And there's a particularly important balance between the ethics of conducting measurements of this kind from a remote measurement vantage point into the country against open DNS resolvers versus the representativeness of the sample that we can get from this type of measurement. On the one hand, it makes sense to send DNS queries to any open resolver in the country, but on the other hand, doing so might accidentally implicate users who have mistakenly left their DNS resolver open to query. The population of DNS resolvers that we're able to query may also present systematic biases in terms of what is reachable or manipulated from those particular resolvers.